In this concept video, we're going to be discussing arc length and sector area. I think the best way to understand this is using a proportion and our reasoning with similarity. You can see that I've already drawn a little bit in here on the circle, and then also I've got degrees here and then radians on the right hand side. One very important note is you need to understand which unit you're using for your angle. So it's either degrees or radians. Either way is fine. We want to understand which one we're using so that we can set these equations up, these proportions up accurately. And also when you're using your calculator, make sure that your calculator is in the right mode. So to understand this, we're going to set up a proportion, and we're going to use the angle measure on the left hand side. Remember, when we write a fraction, we're going to write this as part to whole. So if we look at this circle, we're only looking at this part in red right here, this angle. That angle is going to be theta. That'll be the same for degrees or radians. And we want to compare this, so that's the part of the circle. We want to compare it to all the way around. So all the way around the circle would be 360 degrees. On one side of the equal sign we have the same unit, theta is in degrees, and this is the part that we're worried about, and then all the way around, or the whole, is 360 degrees. For radians, all the way around is 2 pi. So we can write 2 pi down below. You just have to make sure that these two units agree. So even though we see one variable here as theta, you do need to know which unit you're using. Now we're going to set up the arc length on the right hand side. And the arc length is just the distance from a point on the circle to another point. And to do this, we're going to use the arc length as S. And then we want to compare this part to the whole. So all the way around is 2 pi r, or pi d, but in this case we're going to use r. So we'll call this length here r. And then on the right hand side, this will actually stay the same. And you need to be careful here with your units as well, whether you're dealing with feet or inches or anything in the metric system also. Now we're going to manipulate this equation just a little bit. Remember, here we're finding arc length. So generally what you'll see is you'll see S solve for. So if we solve for S here, we're going to multiply each side by 2 pi r. So we'll have 2 pi r times theta all over 360 degrees is equal to S. And on the right hand side, we're still going to multiply by 2 pi r on each side. So we're going to have 2 pi r times theta over 2 pi. The 2 and the 360, we usually simplify this part. So you're going to see this as just pi r theta over 180 degrees. So sometimes your arc length will be written like this. Pi r theta over 180 degrees. This will look different based on whichever textbook or website you're looking at, but essentially the formula is going to remain the same. Sometimes this theta is out over here, sometimes it's theta over 180 times pi r, but essentially you're doing the same thing. And all you need to do is to be able to set up this proportion and reason through part to whole. On the right hand side, we have something interesting that happens here. This 2 pi and this 2 pi in the bottom, that's 1, and then we're just going to have r and theta. So we've got S is equal to r times theta. I really like radians for arc length and even sector area. It kind of makes it pretty easy, and this is a fairly elegant formula that results to find the arc length. Remember, S is the arc length. Here you've got pi in the top and then 180 in the bottom. And here, if theta is in radians, so I'll make an extra note down here about that. Got to be in radians. And this side has got to be in degrees. Just make sure that the units that you're using are matching up. So that's basically it. You can kind of develop the formula if you need to, but here it is if you want to find the arc length. And be careful with some of these problems. You might have the arc length and you might be finding theta or the radius. So let's transition to the sector area concept, and this is going to be very, very similar, except now we're talking about an area, so a two-dimensional unit. And to figure this one out, we're still going to set up the same proportion. Remember, on the left-hand side, we're going to have theta, whatever the angle measure is, and then all the way around, or the whole, would be 360 degrees. If we're using radians, the angle can be in radians, but then all the way around, what we're comparing that to has to be 2 pi. Now we can set up the sector area here on the right hand side. So to do that, we're going to introduce just an A here, and A is going to mean the sector area. So I'll put that up here. Let A equal sector area. Nice thing to define our variables. And that'll be the same on the right hand side. And all of the area of the circle in terms of the radius is pi r squared. So again, we've just set up a simple proportion, keeping in mind our units. And we're going to work with this a little bit. We're talking about the sector area, so usually the A is solved for in these types of problems. So we need to multiply by pi r squared on each side. So we're going to have A is equal to theta times pi r squared over 360 degrees. And then on the right hand side, we'll have A is equal to, we still multiply by pi r squared. And so that'll give us theta times pi r squared over 2 pi. This we really can't do much to simplify that. Kind of is the way it is. Pi over 360, that won't simplify. There's no 2 like there was before in the arc length formula development. On this one over here on the right hand side though, we can do a little bit of simplifying. The pi over pi will cancel. So we'll have the area is equal to theta times r squared over 2. Or sometimes this is written 1/2, then you've got theta and r squared. Note that the radius here is being squared, and you're going to wind up with a unit that's being squared. So if your radius is, let's say, kilometers, then you're going to have kilometers squared. So be careful with your final unit. Remember that we're talking about area here and not a linear length or a linear unit. So either one of these are fine, they mean the same thing. Keep in mind though that this theta is in radians. Don't see any other units around here, so we know that the angle measure is in radians. Here we see degrees, and when we write this fraction, where the formula comes from, it totally needs to be in degrees as well. You're free to use either one, although it's sometimes a little bit easier to use the radian measures. You can see here it's just 1/2 theta r squared. Here you've got some division going on other than 1/2, and you've got a theta over 360 and some other stuff going on. But really either way will work, but try to get used to that radian concept.